Okay, so yesterday we talked about this distributive property. Let's talk about what are some headings that you're going to use to make an outline of the lesson. What did you write down? Annika?
Distributive property.
Okay, the distributive property itself. Good. What else? Faith?
Factor and expression.
Factor and expression. Very good. And the factoring and expression will be a new skill for us today. Let's go down then to our real world link. Okay, go ahead and pause the video at this time and take a minute to complete these and then come back and join us. Pause the video. Okay, let's talk about what you wrote in here. So let's compare our answers together. 3 should represent the 3 friends. 20 should be representing the price of the ticket. And 15 is representing the price of a hat, or a baseball hat. Okay, then they asked you to evaluate the expression in exercise 1. Exercise 1 just means problem 1. So 20 plus 15 made 35. 35 times 3 then gave us 105. What are we really finding there? 20 plus 15 gave us what? Mia?
35.
Which is representing what?
$35.
$35, which is the cost that, what, Elizabeth?
For one ticket and one baseball hat.
Good, 1 ticket, 1 baseball hat, so the cost for 1 person, right? Then we took it times 3 to represent how much it costs for all 3 friends to be able to go. So this 35 is the cost for 1 person. Times 3 gives us 105, which is for everybody all together. Okay, then down below, 3 times 20 represent the cost of 3 tickets. 3 times 15, the cost of 3 hats. If we did it differently and did 3 times 20, this would be the cost for all of what?
The people, all tickets.
All the tickets. This would be the cost for
Hats.
all the hats. Okay, so this is a little bit different than that first one. And then we just add those together to still get this total cost. Is this cost still the same? Yeah, we still get $105. So whether we add the 20 and 15 together and take it times 3, like this, or whether we go 3 times 20 and then add that to 3 times 15, these are still equivalent expressions. Okay, and that's going to kind of link back to what we studied in the previous lessons here in chapter 6. Okay, questions over that? Evan?
I did, for number 5, all I did was just put their equal.
Which is the same thing, that's fine. Colby?
For the 3, when it says like 3 times 20 represents, I put 3 friends times 3.
Okay, let's go ahead and turn then to page 486. At the top of the page, you may want to star this because this distributive property is going to be an essential learning for us here in 6th grade and beyond. Okay? The words we're going to use to describe the distributive property mean to multiply a sum by a number. Multiply each addend by the number outside the parentheses. So what they're saying here is that the number outside the parentheses is going to be shared with each number inside. So we're going to take 2 times 7, that's what you see here, and then 2 times 4 here. And then we could, because those are just numbers, add them together because they're like terms. Look at the algebra one. We sometimes skip this, but let's look at it. What's the thing that's being shared here? A. We're sharing A with B, so that means A times B. We're sharing A with C, so that means A times C. And the operation in between is to add. We're adding those 2 together. Can we combine A and B and A and C?
Yeah.
No. Are those like terms?
No.
No. Over here, though, could we combine these?
Yeah.
Yes, because those are just numerical values. We can actually go back and combine those. Trey?
So are those kind of like simplifying the...
Yeah, the distributive property is kind of simplifying it. It's getting rid of the parentheses, so we're in kind of a simpler form. Okay, and with these numerical ones with the distributive property, we'll actually solve. With these that have variables, you're basically just simplifying to unlike terms. Evan?
So like, once you're simplifying, it's just basically switching the numbers into like an interval and taking up the numbers.
Yeah, yep, essentially.
Okay.
Okay, let's look at the first example. Okay, in example 1 here, it asks us to find 9 times 4 1/3 mentally using the distributive property. So this will help us to solve problems without having to write on a piece of paper. I'm going to write it out just to explain the thinking that should be happening in our head. Okay, so what I really have here is 9 times 4 1/3. But I'm going to break apart this 4 1/3 because that's not very easy to handle mentally. So I could take 9 times 4, couldn't I? And I could take 9 times 1/3. Well, what's 9 times 4?
36.
36. What's 9 times 1/3?
3.
It's 3. 1/3 of 9 would be 3. What's 36 plus 3?
39.
So mentally, I could solve that. Now, I know I wrote it down here, but that's really just the thinking that I'm doing in my head. Okay, if I'm thinking about this, I'm going, okay, 9 times 4 gives me 36. 1/3 of 9 is 3. 36 plus 3 gives me 39. Okay, so this is just going to be a helpful mental math strategy. On the got, it's A, B, and C. I want you to write out, I know you're going to do this mentally, but for the practice of it, I want you to write out the steps that you're going to use on A, B, and C, okay, and show me the mental math that you're going to do. Okay, go ahead with your group at this time. You can pause the video and solve those problems. Okay, Faith is going to show us how to do letter A mentally.
Okay, first you do 5 times 2, and then you get 10, and then 5 times 3/5, then you can cross cancel it, make it easier, and then 3 over 1, what is this, 3, and then you add together, and then you get 13.
Very good. Letter B. Mia's going to show us.
Okay, so for this you do 12 times 2, which is 24, and then you do 12 times 1/4, which you can cross cancel that. This would make 1, that would be 3, which is 3 over 1, which would be just 3, and then you add 24 plus 3, which gets you 9.
Very good. Letter C, Joey.
Okay, so you would do 2 times 3, which is 6, and then 2 times 0.6, which is 1.2, and you add those, you get 7.2.
Very good. Now, obviously, we've written out the work here. If you went back to these, thank you, and we're looking at this, could we do this 5 times 3/5 in our head? Yeah, because if we have a group of 5 things and we're taking 3/5, aren't we taking 3? And here, if I had 12 times 1/4, well, 1/4 of 12 would be really just dividing 12 by 4, which give us 3. And here, 2 times 0.6, I would just go 2 times 6 is 12, move that decimal back one place, then we get that 1.2. Questions on that, Elizabeth?
Do you have to write 7.2 to be right 7.1?
Because they gave it to us in decimal form, let's keep it in decimal form. So we want to keep this as 7.2 instead of 7 1/5. Okay? Whatever form they have, just keep that same form. Colby?
What I did at the beginning, I changed it to 2 times 3 3/5, and then at the end, I changed it to 7.
And that would work too. It might be a little bit easier to go decimals, though mentally. Alex?
Do you have to cross cancel?
No. Is it more efficient?
Yeah.
Yeah. But you don't have to. You'll still get the same answers. Okay, take a look at example 2. Now here's where those algebra tiles from yesterday come in. I use a distributive property to rewrite this. So what this is really showing us is this means that I have 2 groups of this x plus 3. So here's x, okay, right here is x plus 3. 1, 2, 3. Here's x plus 1, 2, 3. Okay, use the distributive property to rewrite it. Well, if we combine our x's, how many x's is that?
2.
2x. If we combine all these integer tiles together,
6.
that would be plus 6. So 2x plus 6 would be kind of like what Trey was saying before. It's just simplifying. Can I combine 2x and 6 any further?
No.
No, these are unlike terms because this one has x's in it and this one's just a number. We can't combine any further, so 2x plus 6 would be our final answer. Evan.
So, I know like from the question, for each group it was 1/3,
Uh-huh.
like 1 and 3. like, it's like that's kind of like it simplified already, but without the x, because 1/3 and then 2/6, isn't it kind of the same with adding x?
I'm not sure what you're talking about.
Like if you have the 1 and like 1x and 3 ones, like can you take that by times 2? Because you have 2 groups.
Well, really, that's kind of what we're doing here, right? We're sharing this 2 with this. 2 times x gives me
2x.
2x. Because remember, when these are smashed together, that means to multiply, right?
Yeah.
This means to multiply 2 times x. I really haven't done anything with it other than I've pushed them together. But this one means 2 times 3. So 2 times 3 is 6. So then I get 2x plus 6. I can't combine any further. Okay? With your group, I want you to go ahead and do letters D, E, and F. Go ahead and pause the video at this time and complete. Typical. Okay, well, let's go ahead and check these. Chase is going to lead us off with letter D. Check your work with Chase.
So first we'd have to take 8 times x, which we don't know x would be 8. It would be 8x plus 8 times 3 is 24. So
Now we have to remember to share that 8 with everything inside the parentheses. So not 8x plus 3, but that 8 we still have to share with the 3 also. Good. Letter E for us, JC. Yeah, Jake? No question? All right, show us letter E.
You do.
And we gotta combine those, right?
Yes.
So when you're sharing, so you shared, let's do it in order. So sharing 5 times 9 would give us, so write that down. Good. And then we're sharing 5 with x, which makes, we still need our operation right in between, right? Plus, here, let's erase and come back to that part. It's not looking right. Can we write 45 again for me? 45 and then plus, right? Now how many x's do we have? So not just x, but I'll go back to your pen. You're okay. 45 plus 5x. Very good. And that one's tricky, just remembering because they switched the order on us, right? Sharing the 5 with that. Okay. You're okay. You're fine. And Aubrey. Letter F.
You have to multiply 2 times x, so it is 2x plus 2x plus 2 times 3 is 6.
Very good. Now I say with these problems, these numbers out here, okay, they're the sharing people. These numbers inside are the people they're sharing with. If you only share with x, that first term, and you forget to share with this next one, these guys get really mad. Okay, we have to make sure that we're fairly sharing. So we share here and we share here to make sure that we're distributing evenly this number outside that we're sharing and distributing. Elizabeth.
Can we not write x because it looks like a times sign?
That's what they're using, so whatever they use in the problem we have to use.
Okay.
Okay, so if they use x, we have to use x. Okay, but I do agree, x is not my favorite variable. Okay, let's go to 487 at the top of the page. We have now in word problem form. Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4.5 centimeters of wire, and each bracelet uses 13 centimeters. Write 2 equivalent expressions, and then find how much total wire is needed. They're asking us for several things here. 2 equivalent expressions, and then find it. Okay, so let's use what we know in the problem. We know that we're making a bracelet and earrings for 4 friends. So 4 friends are getting these. Okay? So if the 4 friends were getting it, let's figure out what it would be for one person's bracelet and earrings. So how long is the wire for the earrings? Jacob?
4.5.
4.5, and we're going to add that to the length for the bracelet. which would be what, Evan?
13.
Do you agree that that's one expression that would represent this situation? Okay, or we could take 4 times the length of the bracelet, no, that's the earring, sorry, plus 4 times the length of the bracelet. Are those 2 equivalent expressions? Okay,
Yeah.
so we did our first part. Now what do we have to do? Evan?
Multiply the 4 times 4.5.
Okay, so we've got to do one of these. We've got to solve one of them, right? How many of you want to solve this one, this first one? Okay, not a huge percentage. How many of you want to solve this one? Some people just don't want to solve, I guess. Okay. So use one of them, and I want you to try and solve that on your own.
This?
What'd you get when you solved? How many of you used this first one? Added and then multiplied? What'd you get? Okay. What'd you get? 70. Those of you who used the second one, what'd you get when you solved? 70 centimeters. So no matter what, we're going to get that Fran needs 70 centimeters of wire. Jake?
I had 132.
Okay, you made an arithmetic error somewhere.
Well, because 4 times 5, this would be 20, right?
Which did you do? Which one did you do?
The bottom one?
Okay, so 4 times 4.5.
Yeah. Oh, I thought that was the dot with the multiplication.
No. That's a decimal. That's why I use parentheses and not a dot, because there's decimals.
You did 4 times 5.
Okay, so that makes sense then?
Yeah.
Okay. Try the got it with your partners, letter G.
Alright, partners.
Go ahead and pause the video at this time and complete. Alright, Jake is going to show us how to solve letter G, writing both the 2 equivalent expressions and finding the total minutes. Go ahead.
So in one day, Martha waits for 10 minutes in one day and runs on the treadmill for 25. So you take 7 times 10, you get 70, and then 7 times 25, and then get 150.
Okay, and I agree
Wait,
with your
175.
solving.
175.
Yes, I agree with your solving, but you haven't written the expressions.
Oh. So would that be 7 and then
So if you do 7 times 10, then what are you going to do with the 7 times 25?
you're gonna add that to the 70.
Okay, so let's show that. Let's do it like this.
Okay.
So show me the 7 times 10.
Like just the way I
Yep, just like you wrote it. Be fine. Prefer not the multiplication sign, but it'll work.
Okay.
Plus, what's the other part?
Oh, 25 times 7.
Okay, so that would be one expression. How else could we show it?
You could do,
Could we figure out how much he works out in one day first?
Yeah.
How would you do that?
well, it says, divide that by like 1. It
Well,
says
this is what he
look
runs,
back
and
in the
he
problem.
lifts in one, and this is
Yeah.
what he runs in one. So how would we figure out how much he did total in that day?
Oh, 35. He did
What did
some-
you just do?
35. I added those together.
Okay, so let's
multiplied
write that
by
over here.
7.
So go 10 times 25. Or 10 plus 25, I'm sorry. And then you said multiplying it by 7?
Yeah.
So let's multiply, put that 7 out front. Are those 2 equivalent fractions, or 2 equivalent expressions there? Okay, so he has this equivalent expression. Could be written like this. I prefer either the dot or the parentheses, okay, but it will work with the x's. Just be careful. Or this expression here. Those are the 2 that we should have. And then he's going to go ahead and solve. So now talk us through solving.
So 7 times 10 equals 70, and then 25 times 7 equals 175, and 175 plus 70 equals 245.
How many of you agree? 245.
Wait,
No.
how? I got that right.
Yeah, 245
Minutes.
Wait. Right?
Well, oh.
175 plus 70, right? Yeah, that's 245. So 245 minutes that he exercised, right? Okay, good. Any questions about how to write those expressions? Any questions about how to solve those expressions? This is using the distributive property. Evan?
For like writing the expression, the answer, I don't get the
Okay, so gotta put the label. It's a word problem, right?
Okay.
Okay, this sixth graders is where I sometimes lose a few people. Okay, we have the next skill is called factoring. So when numeric, that's the ones with numbers, or algebraic, the the expressions of variables, are written as a product of their factors, the process is called factoring the expression. I really need you tuned in right now. This is critical, and if you miss it, this is going to be a hard skill to go back and try to figure out. Okay, so here we have 12 plus 8. Pencil should be in hand. I know it's there, but you might want to do it with me since you've done this. Okay, if we have 12 plus 8, what they want me to do is they want me to factor out a common factor. What is the greatest common factor of 12 and 8? Dawson? Greatest. 4. So what we're going to do is we're going to break this apart into factors of 4. So this really means 4 times 3, and this means 4 times 2. Now, we don't want to write it that way, so there's a more efficient way to write it using parentheses. So I'm going to put the 4 in front, and inside my parentheses, now that I put the 4 out there, that's being shared, right? Left over inside, I have a 3 plus 2. You see that? So what we've done is we've removed that factor of 4 out in front of the parentheses, and what's left inside is what the 4 was shared with. Okay, let's try another one. Find a margin spot. Let's say you have 20 plus 24. And we're asked to factor it. What would the greatest common factor of 20 and 24 be? Okay? 4. So 4 times what makes 20? And 4 times what makes 24? So really, we're going to remove the 4 to the front because we're going to share it. So that gets rid of it here, right? What's left inside? 5 plus 6. Let's check and see if that actually works. What's 20 plus 24? 44. So I'm thinking 44, okay? What's 5 plus 6? 11. What's 4 times 11? 44. Do I still get the same thing?
Yes.
So I could check it. Trey?
How did you get the 5 and the 6?
4 times 5 made 20, right? And 4 times 6 made 24. So when I took the 4 and put it back in the front to be shared, what was left over was 5 plus 6. Let's try another one. Let's try another one, see if it helps, okay? Let's do 14 plus 28. What's the greatest common factor of 14 and 28? Elizabeth?
7.
7 is a common factor, but what's greater? 14. So this would be 14 times 1. This would be 14 times 2. So if I remove the 14, because that's what they had in common, right? That's going to go back in front of my parentheses. That gets rid of it here. I took it, it's out in front. What's left behind? 1 plus 2. You see where I'm getting those from? Okay. Now that's with just numerical expressions. Okay, go ahead and with your group, I want you to try these got it's at the bottom, doing the same process. Go ahead and pause the video and try those. Okay, let's check these ones. Ben's going to lead us in letter H.
So, the common factor that go into both 9 and 21 is 3. And 3 goes into 9 3 times. And 3 goes in 21 7 times. And we write that
Good. How many of you agree and got 3 times the quantity 3 plus 7? Good. Letter I. Monica?
Okay, so both of those you can go into 14 times, so it'd be 14 times 1, and then 14 times 2.
What goes between them? There you go. Good.
And so then you would put 14, 14, and then the extra is 1 plus 2.
Very good. Good. How many of you agree? Should agree because we did that one together, right? Letter J.
So I did 80, and it'd be 8. 8 times 10 plus the 8 times 7, and then I got take out the 8, put it right there with parentheses, and then put the 10 there, and then plus the 7 right there.
How many of you agree with Evan? Got 8 times the quantity 10 plus 7. Good. Any questions that came up about factoring? Are you making sense of it? Jake asked the question, why do we have to do this? It seems like we're making it more complicated. You're right. We won't do this very often, but it's going to lead us to our next skill, which is now they're going to put variables in. And in algebra, when we're dealing with expressions and equations, we're going to see this a lot. Factoring an expression and distributing an expression really are opposites, aren't they?
Yeah.
When I factored, aren't I getting it back to how we distributed before? So factoring and distributing are going to be these opposites, okay? Look on the top of page 5. Not 5, 488, at number 5. There we go. I had 3x plus 15. Excuse me. I'm going to think about this the same way that I just did with just the numerical expression. What do these two terms have in common as their greatest common factor? Faith? 3. This is really 3 times x. Do you agree? Plus 3 times 5 makes 15. So what do they have in common? The 3. So that's going to go back to the beginning. Outside the parentheses, it's what's being shared. I'm going to get rid of it. What's left inside that we have to use? Evan?
X plus 15.
Does this operation change? Is it a plus the whole way through?
Yeah.
What if this were a minus? Would this be a minus?
Yeah.
No, we're just using whatever's there.
X
So
plus
x
5.
plus 5. Now, if I wanted to check my work, could I distribute it and see if I get back to what I started with?
Yes.
So let's do that. Let's check it. This would be your answer, okay? But let's redistribute. If I have 3 times the quantity x plus 5, what's 3 times x?
3x.
3x. What's 3 times 5?
15.
So I get 3x plus 15. Is that what I started with?
Yes.
So that would tell me that my answer checks out. Okay, go ahead and with your group, I want you to try K, L, and M. Pause the video at this time. Okay, Jacob is going to show us letter K. Talk us through what you did. Write as neatly as possible.
4 goes into 16 4 times, and 4 goes into 4x 1 time. So it'd be 4 parenthesis plus 1x and 4.
Good. Now I'm going to show you something. 1x and x are the same thing. So if we're writing this one, we're actually going to get rid of that 1 and just go 4 times the quantity 4 plus x. This 1 is going to be assumed. If it's an x, we know it's 1x. It's like saying I have an apple or I have 1 apple. It's the same thing, okay? So this would be just the better way of writing it. We don't have to put the 1 in front of the x, like that, okay? Good. Letter L for us.
So 7x equals 7 times x, and then 42 equals 7 times
6. And what you do is you take the common factors down here. Add difference u6 plus x.
Yeah, we want it in the order that they give us in the original problem. So let's go back. You're correct in your thinking. Let's just make it in the correct order. Very good. 7 times the quantity x plus 6. Good. I'm going to talk you through letter M, okay, because this one had one tricky thing we hadn't talked about. Okay, what's the common factor of 36x and 30 in those two terms? Casey? 6. So if I'm removing 6, this means that I have 6 times, how am I going to get 36x? What would this other term have to be? Nia? 6x. And this one here would be 6 times what makes 30? 5. Okay? So what's the common factor was the 6, right? We remove the 6. We get rid of the 6 in both situations. What's left over here? 6x plus, what's left over here? Plus 5. If I distribute it out, what's 6 times 6x?
36.
36x. What's 6 times 5?
30.
30. Do we get what we started with?
Yes.
So we'd be good. What questions do you have about factoring with a variable? Colby.
I'm confused.
About what?
Somehow, letter L, I got 7, and then in parentheses I got x plus 2.
Okay. What's your common factor? 7. So this is 7 times x. Do you agree? And this is 7 times 6. What's their common factor? The 7, right? If I remove the 7 to put it out because we want to share it with both of them, what's left behind? X plus 6.
You still find the common greatest common factor.
Yep, it's the same thing as with the numerical ones, it's just we have a variable. Okay, Faith.
Why do you put an x with a number? Why is that any different than I?
Well, the only thing that was different is here we had a 6x. That's what was tricky. Some people were forgetting that to get 36x, we have to have 6 times 6x. Whereas in the other one, we just had it times one of the x's. Okay? Jacob?
So, M, when you get into there's like 6x minus 6x plus 5.
Yeah, this is the answer right here. Okay? Are we okay? Let's try it. Okay, we'll check back tomorrow if we need to on anything that you run into that are roadblocks. Here's what I'm going to tell you. I want you to try it. I want you to go back in your book, okay, and look back at all those things that we've done, okay, as you're working through your homework tonight. If you get frustratingly stuck, meaning you're sitting on a problem for longer than 5 minutes, circle it, bring it to class tomorrow, and when we check and go through it, make sure that you ask the question, okay? It's a 5-pointer, right? If you show me your effort, try it, attempt it, go through it, you're spending longer than 5 minutes on it, put it aside, we'll talk about it tomorrow, okay? On page 489, I want you to do 1 through 13 all. Okay? Page 489, 1 through 13 all for homework. And you can go ahead and get started on that right now. Cameron and Devin, I'm also going to place into Google Classroom another video I'd like for you to watch. If you would please make sure that you watch that one. We watched it yesterday in class, and I think it may be valuable to you. Okay? Feel better? We hope to see you soon.